Okay, hi guys. You should be on page 4 of your notes today. Or no, 5, I apologize. Page 5 of your notes today. And we are going to talk about, it's called, here, Fishy Fishy. So we're going to start with a campus at Fritz University has a fish pond. Suppose there are 20 fish in the pond and the lengths of the fish are given below. And supposedly we catch a sample of 3 fish from the pond and measure their length. What would the mean length of the sample be? And on your worksheet, they tell you they pick a 6.3, a 2.2, and a 13.3. So take a moment, push pause, and get this length, or get this average. Okay, so the average works out to be 7.267 inches. So then we're going to use the random number function on your calculator to find a second and third sample. So let's talk about how to seed your calculator first. So everybody have your calculator out. What you are going to do is in the home screen, you are going to enter your ID. And then you are going to push the stow button. And then you are going to go to math. PRB, and you're going to do number 1 random. And once you have that done, you can then go to math again, over to PRB, and this time you are going to go down to random integer, so that's number 5. And these go 1 through 10, and this is number 11 through 20. So I would do 1 to 20. So for my lower bound, I put 1. For my upper bound, I put 20. And for my n, I'm going to put 1. So this is lower. This is upper. And then I would put n is equal to 1. And then click paste. And you are set. And it's going to find, so like my first number was 19. So 7.7 is going to be the first one I pull. This stow, if you need to go down, is above the on. So if you need to back that up and go back to that. Okay, so what you should notice is that the true mean is 8. And you should notice some means should be closer, some should be further away from 8. So what does that necessarily mean? Means that there's a variability in sampling mean. That means that we have some adjusting to do. We also only have 20 pieces, our sample size is only 20, so that has something to do with it. And we'll get into some of that. So there are about 1,140 possible sample size if we choose 3. So if we were to catch all of those different samples and calculate the mean, we would have a distribution of all possible means. We're going to get into that again. We're going to kind of see some more of that. And this would be the sampling distribution of the mean. This doesn't really let me go backwards. I'm going to go back here. Okay, so the sampling distributions are formed, that would be formed by computing the value of the sample means for every possible sample given from a sample size population. So here, let's just do with 5 given below, and we're going to keep the population size small so we can find all possible samples. So what is the mean and standard deviation of this population? So take a moment, calculate this, put those into stat edit, calculate the mean, calculate the standard deviation. You know how to do this using a list. And you should have found that the mean is 7.84 and the standard deviation is 3.262. So now, from that same thought, we are going to list 10 possible samples with N of 2. In other words, we're going to get 2 fish per pair. So here are all the pairs. And then at this point, this is, and I don't like that color. This is your mean for those. So write those down before we get any further. And then once you have those down, put this in your L1 and find the standard deviation of mean of those. So take a moment, hit pause, calculate those. Write those down and calculate the mean and standard deviation at this time. And you should have gotten a mean of 7.84 and a standard deviation of 1.998. How do these compare to the population and mean above? Well, the mean is the same as above, but because remember, these two are the same, but our standard deviation has decreased. Okay, so let's look at it again. This time we're going to do 3, and the triples are already listed on your worksheet. And this section is your sample mean. So these values are determined from sampling the distribution for mean for sample size 3. So these should be in your new L1. You should put those in L1. Oh. And calculate, hold on, we got a small hiccup here. Let's try this again. Okay, so we did that. We said that this was X bar. This is L1. Oh, that's blink of an eye. Calculate, y'all can't see it. Calculate the mean. Ooh, never mind, it did it for me. And standard deviation is what you should, and this is what you should have gotten. So how do these compare? The mean, these guys, your means are equal, and then our standard deviation also decreased yet again. So what did you notice? The means of the sampling distribution equal the means of the population. And as the sample size increases, the standard deviation of the sampling decreases. So as your N gets larger, your standard deviation decreases. So we have some rules. This first one is the one we've been finding most of. The second one, the standard deviation of the means, is the standard deviation over the square root of N. This rule is exact if the population is infinite and is approximately correct if the population is finite, and no more than 10% of the population is included in the sample. We'll get into some of that in a minute. Note that in the previous fish pond examples, the standard deviation formula is not correct because there were more than 10% of the population. So they didn't quite work correctly when we were calculating it above. Rule 3, when the population distribution is normal, the sampling distribution of the mean is also normal for any sample size N. So we have this picture here. Okay. So we get into this platelet volume metabolic. So this is normal. Suggests that the distribution of platelet volumes who do not have metabolic syndrome is approximately normal with a mean of 8.25 and a standard deviation. And because this is normal, it works. I'm not really liking this setup. So, okay. So from this population, we generated 500 random samples, an N of 5, 10, 20, and 30. Then compute the means of each and the density histogram displayed, resulting in 500. Sample means the mean for each is given in the sample size. So if we look, we have a density here of 5, of 10, we have groupings of 20, and we have groupings of 30. And what you should notice is as we get closer, as we get larger, our columns get smaller. And our standard deviation, so as we go from the upper left to the lower right, the standard deviation gets smaller. But has our mean adjusted as we've gotten smaller? Standard deviation, that's what we've just been talking about. They get smaller. Shape, they get more normal looking. And the mean gets smaller, or stays the same. Sorry, not smaller. Sorry, it stays the same. So rule 4, the central limit theory, when n is sufficiently large, the sampling distribution of the mean is well approximated by the normal curve, even when the population distribution itself is not normal. But the question is, what is sufficiently large? So if we look here, there's the population as n is 14 and n is 16. We're starting to get more normal, but we're not there yet. So how large is sufficiently large anyway? Well, that is the central limit theorem can be safely applied if n is greater than or equal to 30. That is our largest point. So if we look over time period here, if you look at this one, gave time in minutes from the start of the game to the first goal scored. The density data is shown below. Is this normal? No. So we consider this 280 as a population is strongly positively skewed. In other words, it's going towards 0 with a mean of 13 and a median of 10. Using a Minitab, we can generate 500 samples of the following size. And this is our result. And notice what's happened is we've gone from n is 5 to n is 30. It gradually gets more normal the more our n values are. So the more we group them, the better, the more normal it gets. And then our mean starts to level out, and so does our standard deviation. Our standard deviation decreases as we go. These are the density histograms for the 500 samples. And are they approximately centered around 13? Well, let's see, 12, 13, 14. So there's 16. So 13 is going to be about here. 13 is going to be about here. About here. And about here-ish. And actually on this one, let's see, wait, this one should be approximately more. Oh, actually, it's going to be about in the middle. And the same thing goes, it's going to be about here. These are some really bad lines. Sorry, y'all. What do you notice about the standard deviations? They decrease as our n decreases or increases. Shape becoming more normal. And then that is it for today. You have homework to do. It is starting on page 7. 1 through 7 is true, false, and then you get into more about means and standard deviations, and talking about a random sample of 3 and a random sample of 70 and how to do that. And what it should look like for those. If you need questions on your homework, the answers will be provided at 4:30, and we will talk then, along with the notes. Have a good day, y'all.